So that was a very brief overview of Vine, and I wanted to change gears now and talk about another approach to virtual networking that's also available on FutureGrid, and that's a project of myself at the University of Florida, and it's IP-over-P2P with the ability to create group virtual private networks, which we call group VPN. And here, again, the idea of a virtual network is similar. You have applications bound to a virtual network interface, and then you have this piece of software that implements the virtual network, and that's our virtual router in this drawing here. And machines can be connected by across the wide area network. And again, as far as applications are concerned, it's as if you're part of a private network. The applications can use TCP/IP sockets and the TCP/IP stack as they would normally. In this example, again, an application using a website, accessing a website that's available from the other side of the virtual network in a way that's transparent. The difference here with this approach of virtual networking is the nature of this virtual router. In particular, for IPOP, the virtual router forms a P2P network and provides self-configuring routing and uses also a distributed hash table object store to store and look up virtual IP address mappings. So the key techniques behind group VPN is this virtual network IP-over-P2P that provides the basis for tunneling and creating an overlay network for moving virtual network packets around, and then a web interface to configure membership into a virtual private network. So as we'll see later, with this, you can, as a user, go into a web interface and create a virtual network for yourself and allow other users to connect to that virtual network, and then you can deploy your own virtual private cluster. The P2P techniques allow this to be self-configuring, so there's no manager of this network. It manages itself, configures itself, in particular routing, and also does the process of traversing firewalls and NATs autonomously. It also configures addresses for virtual machines using DHCP. The P2P infrastructure allows for nodes to join and leave at any time, and the system configures itself around these events. And the networks can be made isolated, so users can create their own virtual network namespaces and have routing only take place within the machines that are connected to their virtual network. So here's a brief description of under the hood what you have for the P2P overlay. There's virtual machines, each one represented here by a node in this P2P, structured P2P network. And these overlay routers that are connected to each virtual machine can send messages over a multi-hop path that may go through multiple peers. And if messages are commonly sent from a source to a destination, the system creates a direct path automatically for the virtual machines that are communicating with each other. On the left-hand side here, I'm showing a deployment of this peer-to-peer network on a public infrastructure called Planet Lab, and that serves as a mechanism to bootstrap new users into the virtual network. So from a user perspective, you actually do not see any of this peer-to-peer stuff going on. What you see is an interface where you can create, again, a virtual machine, a virtual network, and invite users to join your virtual network. So this is where it begins to close in the description of use of FutureGrid in education. If you create a class on FutureGrid, you can use this virtual network to create your own virtual private network. So you don't have to request that from an administrator. You can go to a website and create your VPN group. And you can tell your students to join that group, and once they do, they can download virtual appliances that allow them to connect to a class virtual private network. In fact, they can create their own groups and create their own private virtual private networks or their own cluster or a cluster that they share with a group of other students. How does the IP-over virtual network allow for this to take place? So multiple users can create their own virtual networks. The key idea here is to use another P2P primitive called the distributed hash table, which basically allows us to do mapping of a virtual IP address bound to a particular namespace. So for example, if I go to the website and I create a namespace called Renato, that's going to be a key that goes into this distributed hash table. And the value that goes into that, associates with that key, is the configuration for the DHCP protocol. So any other machine that connects to that namespace will get an address that's routable only within that namespace, Renato in this example, and they'll get automatically an IP address within that namespace that will not conflict with IP addresses of other users. The distributed hash table is also used to look up mappings between a virtual IP address to a P2P address, and that's a mechanism that's used under the hood by the virtual network to enable seamless routing of virtual IP packets over the overlay. So going back to our view of virtual networks, again, you can still have that capability that I showed in the beginning, where you have multiple virtual machines connected, and you can have multiple virtual networks instantiated on top of the same infrastructure. Here we have networks N1 and N2, and these could be the actual namespaces that are used by these two networks. And each virtual machine on virtual appliance on each one of these networks gets a virtual IP address that's only routable within the context of its namespace. And the DHT is used as the mechanism to look up mapping of namespace colon IP address to a P2P address. Again, I covered this already. If virtual machines like A and B here begin to send lots of messages to each other, the network adapts itself to create a direct connection and avoid going through multiple hops in the overlay network. So here's one example showing how this virtual network is able to actually connect multiple cloud providers together. This is one experiment where we ran virtual machines on different sites and connected by the virtual network. And as you can see, there's an overhead induced by the virtualization layer, but when you're crossing the wide area network, this overhead tends to be small, and for many applications is one that can be afforded, and again, with the benefit of providing a logical virtual network that makes clustered applications work easily.